Hey everybody, happy start to the week. It's Monday, May 18th, and it's time for another Chemistry 1 lesson. But it wouldn't be Chemistry 1 if we didn't start with the best part of the day. The joke. What do you call a beehive that has no exits? You know what you call it? Unbelievable. Because there's no exits. They can't leave. So what are we doing today? Well, it says that our objective is we're going to review moles as a unit of measurement in chemistry. Okay, so last week I introduced the concept of moles to you. We talked about what a mole was equal to. We talked about molar mass. We did some conversions. And I got some comments from people and some emails and whatnot with a little bit of confusion on what's going on. So tomorrow, Tuesday, May 19th, I'm going to do a Google Meet. I posted about it in the Google Classroom. And if you can join me at 11, if you have any questions about stuff, we'll go over it. But today, I'm going to review the basic concepts of moles with you. And then tomorrow and Wednesday, I'm going to review the math stuff, okay? But if you have any pressing questions, make sure to ask me tomorrow during the Google Meet. Or if you can't make it, make sure to comment on the Google Classroom post. Make sure to email me, whatever you'd like. I'm more than happy to help. I want you guys to get this, okay? Especially if you're moving on to Chem 2 or AP Chem, because this stuff's going to come back, okay? So anyway, we're going to review moles as a unit of measurement. So this was Chapter 10, Chemical Quantities. So the basic concept was this. In chemistry, 1 mole is equal to 6.02 times 10 to the 23rd representative particles. Now again, don't be confused by that times 10 to the 23rd. It's not a problem to solve. That's scientific notation. It's just a way to write that number. If we wrote it out, it would be 602 followed by 21 zeros. Okay, we write it that way so it's more compact. But basically, that idea is just like saying 1 dozen is equal to 12, 1 pair is equal to 2, 1 mole is equal to 602 hextillion. Okay, and we do that to count particles in something. What are particles? Well, the 3 types of representative particles are atoms, molecules, formula units. Representative particles are the pieces that represent the substance. Okay, so in an element, it's an atom. In a covalent compound, the smallest piece is a molecule, like water, it's H2O, 2 H's and an O together. And formula units are for ionic compounds, like table salt, where it's NaCl, a sodium and chlorine bonded. Okay, so that's the basic with a mole. The mass of 1 mole is called the molar mass, and that is key here because while it's good to know that 1 mole is specifically that many particles, we have no way in reality to count that many particles. It's good to know it's that many and it's defined as that, but how in the real world can we count that or figure out what 1 mole is? Well, we can do the molar mass, okay? Every substance has its own definitive molar mass. It is the mass of 1 mole of that substance. Now, how do you figure it out? Is there a list of it somewhere? Technically, there is. It's the periodic table, okay? For elements, the atomic mass of the element with grams as the units is the molar mass of that element. So basically, for any given element, as long as it's, just single atoms, the molar mass is whatever the atomic mass is on the periodic table with grams at the end. For example, let's look at carbon. Carbon's molar mass would be 12.01 grams. That would be the mass of 1 mole of carbon. How did I get that number? You need to look at your periodic table. Go to where carbon is and look at the atomic mass. It says 12.01, correct? Put grams at the end. That is the mass of 1 mole. Meaning if you had 1 mole of carbon, it would have a mass of 12.01 grams. Okay? For compounds, it's a bit trickier because they're made of more than one thing. So what you have to do is you have to add up the atomic masses of all the elements involved, and then you use grams as the units again. What does this look like? Well, let's look at carbon dioxide. What's the formula for carbon dioxide? Hopefully you got it, and it's CO2. So what that means is that compound is made of 1 carbon and 2 oxygens. So we start with carbon. It's 12.01. Now I put times 1 here. Why? Because carbons, there's only 1 of them in the formula. So it's the mass of carbon times 1 to represent how many there are. Plus 16.00, that's the mass of oxygen, times 2. Why did I multiply it by 2? Because there's 2 oxygens. So we have to get the total mass of all those oxygens. 12.01 times 1 is 12.01 plus 16.00 times 2 is 32.00. Add it together, and it's 44.01 grams. So there you are. 44.01 grams would be the mass of 1 mole of carbon dioxide. And that is the basics on mole we talked about. Remember, a mole is a number of particles. But in the lab, we can calculate how much 1 mole is or how many moles of something we have based on the molar mass of something, okay? We get the molar mass from the periodic table. Nice little review today, guys. There is an assignment going over the things we talked about today, so make sure to get that done. If you have questions, comment on the Google Classroom post, send me an email, whatever you would like. And don't forget, Google Meetup on Tuesday, May 19th, okay? It'll be at 11 a.m. The link will be posted in the Google Classroom, so make sure to join me, okay? Otherwise, I hope you all have a great day, and I hope the week goes very, very well. I'll catch you all tomorrow.